Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone and welcome to another video in machine learning with Scikit Learn. And today's topic will be touching the concepts of classification. A classification is a part of machine learning in which you have to determine the class in which a specific data or an instance will fall into, and in that the first algorithm that we'll be considering is the logistic regression or the binary classification part. So in this video we'll be looking at what is classification using the logistic regression, as it sounds as regression but how it's classification. And followed by that we'll be looking into iris datasets and then followed by an example for the same. So let's get started. So here's a Jupyter notebook and we're talking about the classification. Now, since in regression we were given a specific data through which we needed to predict a specific value. Now, for example, if it was given to 1 to 9, a specific value, you have to predict a value for 10. But in classification, what happens is there will be an instance of the classes in which you have to classify which of the object will fall into which specific category. To understand that, let's look at the basic function of classification that is known as sigmoid function or the logistic regression. Now, in sigmoid function, it is given as 1 by 1 plus e to the power of minus t, for which t value changes on the x-axis. Now what happens is the value which are crossing at the value of 0.5 here, the values above that will be considered as 1, and the values which are lesser than 0.5 will be considered as 0. That is by the far the simplest definition of sigmoid function that you need to understand. So if it's having a specific threshold in which the sigmoid function by default is having 0.5 and above that is classified as the category of 1, else the value lesser than that is classified as the value of 0. So let's look at the data set that we are using today and followed by the example. So we are calling our necessary libraries, and today we'll be using a special data set provided in Scikit Learn. That is, in Scikit Learn it provides a specific subclass of data sets. Inside that we have the iris data set. Now iris data set is a very small data set and a very old one, and it's been used for the basic classification purpose over a long period of time. In today's video we'll be looking at the same. Now iris is a flower, and Scikit Learn has given the iris dataset consisting of 3 different type of irises flowers, that is Setosa, Verisocula and Virginica, that depends on the different size of petal and sepal length which is being stored into a NumPy array. Now as we can see, the shape of the data says 150 into 4. 150 defines as the number of rows followed by the number of features or the column as 4. It's one of the sample of the data sets which are provided in Scikit Learn. So as you can see, this is the iris flower that we have, and today we'll be classifying the 3 different types of iris flowers according to the petal and the sepal length given to us. So from Scikit Learn datasets we have called load iris. Once that is done, it's basically classified into 2 things, that is the data and the target. In X we take the data, in Y we take the target. After that, what we do is that we need to split the data sets for testing and training purposes. So what happens is we'll be using a specific set of values for training and specific set of values for testing, after which the training data is the one on which the model learns how closely it can fit or what are the classes through which a specific feature is provided, the value can be taken. That can be done using the model selection model train test split function. Now train test split gives us the output of 4 values, that is xtrain, ytest, ytrain and ytest, when we load the basic x and y values, followed by the size of the test size that we have. Now we can have the test size either as 20% or 25%. Now since the data is very small, we'll be taking as 20% as the test size and 80% of the data for training purposes. Followed by a very important parameter provided is the random state. Now random state simply saves your data from snooping bias. What happens is when you give a specific random state to the value, each time you run your model, the data will be separated in the same manner of a same random distribution. If that is not followed, what happens is eventually after a modeling, your complete model looks into the complete data set and it's nothing there to predict for the same. Now if it predicts the value, that is leads us to the snooping bias. So random state is a very important parameter and it can be given any values according to 1. So we give 42, it can be given 0 or 5 or anything like that. So let's keep 42 for now. So here we got now 4 different data sets and we'll be putting xtrain and ytrain to training, followed by xtest and ytest for testing purposes. Once that is done, what we have done is we have called the Scikit Learn pre-processing library. Inside that we need to standardize the values which has been provided in the data sets. Now as you can refer from the pre-processing videos, scalar or the changing the value to a specific standard is very much important, as it helps you not to get any biased model or the training. So what we do is we call the instance as sc and we fit and transform the xtrain value and the xtest value. Once our pre-processing is done, we call the specific logistic regression value. Now the logistic regression still considered as the regression term, as it still uses the sigmoid function but still works as classification value. So once that is done, we call it in a random specific state of 0, and then once that has been called, we fit the value of xtrain and ytrain. A fit function is simply means to train the model on the given dataset, as it's the same is compared to the almost every library in machine learning. So let's run it. Now it's been running and we got the specific and default parameters, and let's predict the value which has been given for xtest we have. Now if we look into it, we have y test values and now we have y predicted values. So we can compare the original value with the predicted value we have. Once that is done, it gives us the closeness of how much accurate our model have been.